number is just something that we use with magnitude, which is going to basically be the size of something. And a vector is something with magnitude and direction. So a vector tells us which direction it's headed. The scalar of a vector is a speed or magnitude, and it will be denoted one of two ways. They'll either use double bars to say it's a vector, or they also could just use a single bar, like this. So, although that does look like absolute value, it's not denoting absolute value, it's denoting magnitude. Basically, magnitude is going to just figure out like the size or distance. So it says vectors can be added and subtracted, and that would be where you pick up one vector and place its tail or starting point at the head or the ending point of the previous vector. So you would draw one vector, and where that one ended, you would start the next one. It's important to remember when we do these that you keep each vector's size and direction the same when moving them, okay? Whenever we're subtracting, though, we're going to go in the opposite direction, right? So if you want to make a little note of that, you can say, except when subtracting. All right, so on example 1, they drew a picture for us here with vectors u, v, and w drawn on the coordinate plane. So if I wanted to know the vector for each of these, I just look at where its terminal point is or where its ending point is. So for vector v, it ends right here at this point, which is at -5, 3. So I would say that vector v is vector -5, 3. So instead of parentheses, you use these. They kind of look like the greater than and less than signs. That's how we will notate a vector versus a point. All right, so then what would be our vector for vector u? Right. 2, 2. All right, and what about vector w? Where's that one? Good. Okay, so now that we know all of the vectors, we should be able to find the following. So on part A, it says vector u plus vector v. So I'm going to go ahead and draw vector u. So we would start at 0, 0, and we, for vector u, are going right to and up to, right? So this is our vector u. All right, and when I am adding vectors, like it says up there, we start the next vector where that one ended, okay? So if we actually were to move the amount that vector v is, that would be -5, 3, right? So from where I just left off, I would count 1, 2, 3, 4, 5 places in the negative direction, and I would count up 3 places. So my vector v should end up here. Okay, so we can find this by graphing. You also can find this by literally adding the vectors. So we know that vector u is the vector 2, 2, right? And we know that vector v is the vector -5, 3. I could just simply add these two vectors together. I'd add the ones that are kind of like my x components. So 2 plus -5 would give us what? Right? And 2 plus 3 would give us 5, right? Which is exactly where we just plotted this point for the terminal spot of vector v. Okay? So Like I said, you can do it graphically by just counting the points, right, of the size of the vector. Or if you wanted to do it algebraically, you could just add them together, and it should tell you where your terminal spot is, okay? If we were trying to find the distance from the starting point of vector u to where we ended up, okay, the shortest way to get from where I started to where I ended would be to go straight there like this, right? So that would be what we refer to as the distance, or they might call it like another vector, like vector r maybe. All right. Okay, let's do another one. All right, now B, part B says this time we're starting with vector u and we're going to subtract vector v. So again, I'm starting with vector u, which we know is at 2, 2. But because I'm subtracting, I'm actually doing the opposite of whatever it says to do, right? So instead of going left 5 units, I would go right 5 units. And instead of going up 3 units, I would go down 3 units, which would put me over here. So this was u, this was v. And again, I could have done this mathematically as well. So we could have done 2, 2 minus negative 5, 3. Well, 2 minus negative 5, 2 negatives actually make a positive, right? So that'd be 7. And 2 minus 3 is negative 1. And sure enough, that is where we ended up plotting our next vector, right? And again, if they were asking like for how I would get from where I started to where I ended, the shortest way would be to just kind of cut across here like this, right? Okay. All right, part C. This one says 2w plus v. All right, well, w was 2, negative 3. So if I were to go and plot that, 2, negative 3 would be, let me switch back to black. 2, negative 3 would be here. But it says to do that twice, right? 2 times. So from here to here would have been once, and then I'd have to go over 2 and down 3 more to do 2w. All right, so here's our 2w over here. And it said to add v. So I'm going to truly do exactly what vector v says, which was negative 5, 3, which means 5 places to the left and up 3 places, right? So I'll count left 5 and up 3, which would put me here. So there's v. And again, if they wanted the shortest distance to get from where we started to where we ended, I'd take the shortcut, right? And I could do this mathematically as well. So I could do 2 times w, which was 2, negative 3. Basically, I would just distribute that 2 into the vector, which would give me 4, negative 6. And then I would add vector v, which was negative 5, 3. So when I add, I'd get negative 1, negative 3, which is exactly where we plotted our final point right here, right? Okay? All right, I want you guys to try parts D and E. So they wrote it, I know the 2 is kind of funny. This just means 2 times vector u right there. I know that looks kind of funny. I don't know why it's spaced so differently, but that's what it means. 2 times vector u plus vector v. So you guys try D and E, and then we'll share what we come up with. subtract, we're going in the opposite direction. So on part E, keep that in mind. Whenever you subtract 2W, go the opposite direction of what it says. All right, looks like most of you guys have that. So on part D, the first thing I would need to do is double U. All right, like go 2 places in the U direction, or if you're doing it mathematically, just multiply it by 2, right? And so instead of just going over 2 and up 2, I'm going to go over 2 more and up 2 more, which is going to put me at 4, 4, right? So from here to here, here to here. So this would be our 2U, okay? All right, and then it says to add V. Well, since I'm adding it, I'm truly going in the direction that it says. So I would go 5 places to the left and up 3 places, which should put me right about here. So there's my vector V, and then this would be our shortcut, right? And then if we're checking that mathematically, like we said, if we doubled U, it instead of 2, 2 becomes 4, 4. And then I would add my -5, 3, and I'd get -1, 7 for my final spot, right? Okay? All right, and then for that next one, we do V first. So -5, 3. So there's vector V. And then it says to go -2W or -2W. So W was 2, -3. If I double that, it becomes 4, -6, right? And I'm going to go in the opposite direction. So instead of going right 4, I would go left 4. And instead of going down 6, I would go up 6. Good. Which puts me kind of right off the edge of our graph here. All right, and then our shortcut would be here. So here we'd have our -5, 3 minus, if we double U, we had 4, -6, we said, which will add to give us -9, 9, which is where we plotted our points. All right. Okay, so now that we know how to graph our vectors, flip it over onto the next page, and it says, given some point A, any coordinate point with some x and y value, and some point B with some x and y value, it says the component form of a vector AB would be written as the x value from your second point minus the x value from your first point, and then your y value from the second minus your y value from the first. So to write it in vector form, you subtract your x's, you subtract your y's. The order you subtract does matter, right? Because if you subtract A from B, then you would have a different sign, right? Because 3 minus 2 gives you something different than 2 minus 3, right? It changes that negative sign. So order will matter. and you'd be off because your vector is going to be going in the wrong direction. So it says the magnitude of your vector AB is the length or distance. So like I was telling you guys on the front page, it can be denoted in this way. It kind of looks like absolute value bars, but really they're asking for magnitude. And your magnitude is just the length or distance something is from where it started. Okay, so back in geometry, you learn this distance formula where it actually is derived from your vector, right? Still x is subtracted, y is subtracted, but we square them, add them together, and take the square root. Well, if I'm squaring something, it doesn't matter if I got a positive or a negative. When I square it, it becomes positive, right? That's because distance is never negative. So if you sketch your vectors, you could also determine their magnitude basically using Pythagorean theorem, that side that we were drawing in red, right? So it says that the magnitude is just the distance between A and B. The order or the direction wouldn't necessarily matter because, again, if we square it, it becomes positive. All right, so for part A here, it says that this is some coordinate point. So this is my XA, YA. And then point B, this is going to be my XB, YB. So when they ask for the vector, this is where order does matter, right? And they said that it would be XB, which for us is 5, minus XA, which for us is -3. And then, nope, sorry, I just combined, I combined them, okay. All right, and then we've got, for our y values, -1 minus 2. And then I would just simplify. So what is 5 minus -3? 8, good. And -1 minus 2? Very good. So that would be our vector, right? Because the direction matters here. So it does matter that we have the 3 being negative and the 8 being positive. Here, when it has those lines around it, that means find the magnitude or the distance, okay? Well, that distance formula that they put up there for us was under the square root, and it said it should be x sub b minus x sub a. Well, we already did that, and we got 8, right? So I'm just going to plug in an 8 for that spot, and it's supposed to be squared, plus your y sub b minus y sub a. Well, we already did that as well, and we got -3. It just needs to be squared for the formula. All right, well, what is 8 squared? 64. And what is -3 squared? 9. So I got 64 plus 9, and 64 plus 9 is 73. Does 73 have a square root? So if we want to keep our distance exact, we're just going to leave it as square root of 73. If I were to draw this vector, it started at the point -3, 2. That was my point A. And it ends at point B, which they said was at 5, -1. So this would be vector AB, going from point A to point B. All right, you guys do example B. All right, so again, this was our x and y, our x and our y. So what did we end up getting for vector AB when we subtracted our x's and y's?
-5, -8.
Right. As long as we put them in the right order, we should have gotten -5, -8. Good. All right, and then that meant for distance, we would just square those two values and add them, right? So what did we end up with for our magnitude or our distance? Square root of 89. Very good. All right, and again, we start at point A, which we were told was at 4, 5. And we end at point B, which we were told was at -1, -3. So our vector would look something like this. Okay. All right, flip it over onto the next page. All right, and we kind of already touched on this on the front page, but we're going to go into a little more depth with that vector operations. So if this is your vector u and this is your vector v, like we said, whenever you add the two vectors, you add the things that are in the x value places, which in this place are the a and c, right? So I would add those two things together. And then I add the y-like values, which in this case are b and d. Same thing for subtraction. You subtract the x's and you subtract the y's. For scalar multiplication, like we were saying on the front, it's kind of just like distributing, right? So if I multiply something by k, I'm just multiplying both the x and the y component by k. So it says example 3, if vector u is 1, 4 and vector v is -3, 2, find both algebraically and geometrically all of these operations. So algebraically would mean like what they showed you in the box up here. Geometrically would mean just counting it on the graph, okay? So if I were doing it algebraically, like they said, if I add these two vectors together, I'm really just adding the things that are the x's and adding the things that are the y's. So here, what would I get when I add 1 and -3? Okay. And when I add 4 and 2, 6. Okay. And then for our vectors, if we did it geometrically, we'd be doing what we did on the front page. So you do know where you're going to start, 0, 0, right? And where you should end up, -2, 6 is where I should end up. But if I didn't do the math, if I was just doing it geometrically, I would start at 0, 0. And I would do vector u, which is 1, 4. And then I would do vector v, which would be 3 places to the left and up 2 places, which would put me here, which is in fact at -2, 6, just like we said it would be. So this would be the vector that we came up with. All right, you guys do B and C. All right, so on part B, when you guys solved algebraically, what did you guys get for your vector? 4, 2. Okay. And whenever we graphed it, we would have graphed u first, which would have been at 1, 4. And because we're subtracting, we know we go in the opposite direction of what vector b actually is, right? So it says to go left 3, I'm going to go right 3. It says to go up 2, we're going to go down 2. So here was u, and here was v. So this would be the shortcut, the magnitude, the distance, right, between our starting and ending points. Okay. All right, and then C, this one actually didn't ask you to add or subtract anything, just multiply, right? So this would be 2 times the vector negative 3, 2, so we end up getting, good. So whenever we graph this one, we started at 0, and we went negative 3, 2, but then we had to do it again. So from here to here would have been 1, but we kept going 2 times. So we just doubled that vector, basically. So if I was trying to look for the shortcut, there's not necessarily one here, right? You just still travel along the same line to get there. All right. Okay. So on the very last page, this one gives us 3 different vectors, vector u, v, and w. And they ask us to perform different operations. Now here, they're asking us to multiply and add. But if you notice on some of these other examples, it has these bars. And what do those bars mean again? Distance, right, magnitude. So my final answer on ones like this would be under a square root, right? Okay, so for the first one, we're just doing operations. So this would be 2 times vector u, which is negative 4, 5, plus vector v, which was 8, negative 10. So order of operations would tell me to multiply first, right? So when I multiply by 2, I get, good. And then I'm going to add 8, negative 10, the vector. And what's that going to give us?
0, 0.
Right. So easy enough. They did not have any bars on there, so they didn't ask us for magnitude or distance. So that would be it. That's where I'd stop. Okay. All right, number 3, not number 3. Letter B, on the other hand, does have absolute value like bars on the whole thing. Remember, also they could do double bars. Just know that that would mean the same thing, right? It just means once we find the vector, find the distance of said vector, right? So here we're going to have vector W, which was, and I'm going to subtract 3 times vector U, which was negative 4, 5. All right, so if we are using order of operations, we're supposed to multiply before we would add or subtract, right? So I need to distribute this. All right, so negative 3 times negative 4 is going to give us, right? And negative 3 times 5 will give us, right? Okay. And I distributed the negatives. So now when I'm combining, I'm actually just adding them since I already distributed the negative. All right, so then I add these two together. And what do we get when we add negative 6 and 12? Right? And 1 and negative 15? Right. Okay, so now we've come up with the vector. But remember, it had these bars on the outside telling us they want the magnitude or the distance, right? Okay, so remember, on the previous page, we said that that should just be whatever we got when we did this term, which was 6, right? So we'd have 6 squared plus our second term, which was negative 14 squared. All right, well, 6 squared is, right? And what's negative 14 squared? Anybody know that one? Well, we know 12 times 12 is 144, so it's got to be 196. Very good. Perfect. All right. Okay, and then what is 36 plus 196?
232.
Good. All right, now there probably is no perfect root for 232, but it surely can simplify, right? Do you guys remember how we simplify radicals? You look for the number that goes into it that does have a square root. So what would be a number that might go into 232 that does have a square root? What do you guys think? It's even, right? Possibly. But even if 16 doesn't, what's even smaller than 16 and has a square root? 4. So 4 definitely goes into it. So actually 4 times 58 gives you 232. I can take the square root of 4, which would be 2, right? But I can't take the square root of 58, and there's nothing that multiplies to give me 58 that has a square root. So it would just simplify to 2 square root of 58. Okay? All right. Part C, kind of the same idea, but they said find the magnitude or distance of just this part, and then the magnitude or distance of just this part, right? Because they put the magnitude bars around this and the magnitude bars around this. So I've got to find them separately, okay? So for W, we're going to have -6, 1. And it does not say to perform any operations there, right? No multiplication or anything inside there. And then we're going to have minus. Now in this other one, we do have 1/2 that we're supposed to multiply by vector v, which was 8, -10. So whenever I multiply, what am I going to get there? Okay. All right, so now that I have come up with the vectors, I have to find the magnitude for each. I can't combine them, right, because they said find the magnitude for that first one, find the magnitude for the second one, which would be different than if I actually subtracted them and then found the magnitude for them together. So for the first one, we got, what would that be? -36. All right, so this would be positive 36 plus 1, right? If I were to put it under here, this would be -6 squared plus 1 squared. When I square the -6, it becomes positive. So this would become square root of 37, right? Okay, minus, for this one, I got 4 squared plus -5 squared. What would that be? What is it? 41. So this would be square root of 41. Neither of those are going to have a square root, nor are they things that we can simplify. So I'd have to leave their magnitude just like this. All right. Okay, part D. On part D, it looks like they have us doing operation to the vector in the top. In the bottom, they have us doing an operation and finding the magnitude, right? But it does not say to find the magnitude of the top. So we'll leave the top alone once we multiply. So we'll have 3 times vector u, that -4, 5, over in the bottom, vector v, which was 8, -10, plus vector w, which was -6, 1. All right, so in the top, I distribute. What's that going to give us? Good. All right, and in the bottom, we're going to add. So 8 and -6, 2, -10 and 1. Right. Okay, and then remember, it did have those magnitude bars around the denominator. So I do need to find the magnitude or the distance of the bottom only. Okay, so this would actually mean I'm doing 2 squared plus negative 9 squared under that square root, right? So I'm leaving the top alone. But in the bottom, that 2 squared is 4, and negative 9 squared is 81. So what would that give us? Square root of 85. All right. So we simplified what they asked for. Now remember, a lot of times they like for us to do what we call rationalize the denominator, where we don't leave the square root in the denominator. And remember, to make that happen, all you do is multiply the denominator by itself, right? So I would just multiply the denominator by square root of 85. But if I do that in the bottom, got to do it in the top as well. So we would end up with square root of 85 times the vector negative 12, 15 over 85. All right.